right, in this video, we're going to do some numerical problems with price discrimination. And to do that, we are going to use this table version of a monopoly problem. So in previous videos, we've looked at graphs to help us understand monopoly behavior. Here, we're going to use a table so that we can really, zoom in to think about individual consumers within this market and how we might price the product differently for different consumers. So the way this table works is what it's showing you is it's showing you the demand curve. And here each customer is interested in just buying one unit of this product. So these are all of our potential customers here. And we also have their reservation prices, how much they're willing to pay. And together this tells me for any given price, how much consumers will purchase. So this represents demand. If I set a price of $16, I know that only one person is willing to pay $16, so I would get a quantity of 1. If I set a price of $14, I know 2 people are willing to pay at least $14, so I would get a quantity of 2, and so on down the table. And your table will always be set up this way, so the reservation prices are ordered from highest to lowest. So you can just write your quantity 1, 2, 3, 4, 5 on down the table. All right, so the first question in this problem is what is the socially optimal quantity of shirts in this market? So remember, socially optimal is competition where price is equal to marginal cost. So we just need to go back to the problem wording and pick out what the marginal cost of this product is. You can see here that we have a marginal cost of $5 and a fixed cost of $2. So if the price was $5, how many people would buy this product? The answer is all of them. They're all willing to pay more than $5 to buy this product. Now, what if the marginal cost had been $7? If the marginal cost were $7, then the socially optimal quantity would have just been 5 of the consumers because 5 consumers are willing to pay more than $7. All right, but in this example, all 6 customers are willing to pay more than $5, so our socially optimal quantity is equal to 6. So the next question is, how many shirts will the firm sell if this is a single price monopoly? So this is going to be similar to what we did in those graph problems earlier in this topic, where we calculate marginal revenue, then we produce as long as marginal revenue is bigger than marginal cost. Single price monopoly. If we have to charge one price to all of our customers, then we're going to treat them all as one big group, calculate our marginal revenue, and then, of course, produce as long as that's higher than marginal cost. So it's really the same steps that you took in the graph problem, just applied in this different context. And the main difference here is in how we calculate marginal revenue. When we had the graph problem, we could just use the equation for demand, multiply the slope by 2, and we had our marginal revenue equation. Here we actually need to calculate marginal revenue for each unit that we're selling by first calculating total revenue and then calculating the change in total revenue as we move down the table. All right, so total revenue is just price times quantity. So if I set a price of $16, I'm going to only sell one unit, and I would have a total of $16 at the end of the day. If we set a price of $14, I would sell 2 units, and I would get a total of $28, right? And I'm multiplying here just price times quantity as we move down the table, right? If I set a price of $6, then I'm going to sell 6 units, and that's going to give me a total revenue equal to $36. All right, so now marginal revenue we can find by taking the change in total revenue over the change in quantity. But luckily for us in this table, we're always going to have an increasing quantity as we move down the table of 1 unit, right? So we can kind of just ignore that denominator and just think about how much total revenue is increasing. So if I sell 1 unit, that adds $16 to my revenue. If I sell 2 units, now I want to look at the difference between 28 and 16. That's going to increase my revenue by $12. Selling the 3rd unit would increase my revenue by $8. The 4th unit increases revenue by $4. The 5th unit doesn't increase my revenue at all. And the 6th unit actually decreases my revenue, right? So I definitely don't want to do that. Now we have marginal revenue. We want to remember that the firm wants to produce as long as the marginal revenue is higher than the marginal cost. So we just need to compare that to our $5 marginal cost. And then we can see that the firm will stop producing here after 3 units, because that's the last place where your marginal revenue is higher than your marginal cost of $5. Producing the 4th unit, okay, only earns us an additional $4 in revenue, and it would cost $5 to produce, so we're going to lose money doing that. Now here you can see like a little bit of the, I don't know if I want to call it a paradox of monopoly, but a little bit of a puzzle, because this 4th person, right, David Bowie, is willing to pay $10 for this t-shirt. In fact, my son has a David Bowie t-shirt. It's like his favorite shirt, and he just wears it all the time. It's a little bit of a tangent. But David Bowie is willing to pay $10 for this t-shirt. We can produce the t-shirt for $5, so why can't we make money selling this t-shirt to David Bowie? It's because in order to sell the t-shirt to David Bowie, we have to lower the cost to $10, not just for David Bowie, but for all of the customers in this market. So we're losing $6, right, by lowering the price from 12 to 10. We gain the extra $10 in revenue from selling to David Bowie, but we lose $6 in revenue selling to Adele and Beyonce and Christina, right? So that's why you've got a marginal revenue here of only $4. Okay, so the answer to the question is that the single price monopoly is going to sell 3 t-shirts, and that's going to earn them some profit. So we want to calculate profit. Keep in mind that profit is total revenue minus total cost. So that's going to be $36 is my total revenue, price times quantity. And now to calculate total cost here, we want to add up all of our fixed costs and our variable costs. So our variable cost here, that's the marginal cost, that's constant, and it's always going to be constant in these problems. So your total cost you can always calculate as your marginal cost times your quantity plus your fixed cost, because I'm always going to give you a constant marginal cost in this example. So here, t-shirts cost $5 per unit to produce. So my total cost will be $5 times the number of t-shirts plus the fixed cost, that's $2. So we get 36 minus 17, and that'll give me a total profit of $19 for the single price monopoly. All right, now we want to add in here price discrimination, and this is something that we can do since the problem is this is something we can do now since the problem is in a table rather than in a graph. So how many firms should the business sell? How many t-shirts should the firm sell if it's going to charge different prices to women and different prices to men. So now we have two groups of consumers here. Okay, I'm going to separate them. We've got women and men. And this dividing line does not necessarily need to be at the same place as where the single price monopoly was producing. The dividing line could be anywhere. But basically, we have one group of people who's willing to pay higher prices and one group of people who's not willing to pay the high price. They're going to only be willing to pay a lower price. We can now charge different prices to each of these groups. And you'll notice if you ever go to buy like a t-shirt at a concert or something like that, the women's t-shirts will cost more than the men's t-shirts. Why? I don't know. Women are, I guess, on average, willing to pay more for clothing than men. It doesn't have to do with the cost of the t-shirt, right? So this is a good example of price discrimination. All right, so now that we have our two groups, we're just going to do exactly the same thing that we did before. We're going to calculate total revenue and marginal revenue, but we're just going to do it separately for each group, right? So because I can charge one price to men and one price to women, we have two separate markets, I'm just going to treat them separately, and I'm still going to maximize profits by producing as long as marginal revenue is greater than marginal cost. So the good news is that we've already done this for the women. The women, nothing has changed here because the women are still the first, second, and third consumers in their group. Okay, so their marginal revenue is exactly the same as what we calculated before. We only need to recalculate total revenue and marginal revenue for the second group of consumers, in this case, the men, because these people are no longer the fourth, fifth, and sixth consumer. They're the first, second, and third consumer in that group. So our total revenue then, treating the men as a separate group, will be 1 times 10, that's 10, 2 times 8 is 16, and 3 times 6 is 18. And then our marginal revenue will be 10, 6, and 2. All right. So for the first group of consumers, right, for the women, nothing has changed. We're still going to sell 3 t-shirts to the women, and we're going to charge a price of $12, right? We always want to go back to our reservation price to get the monopoly price. Sometimes people get confused and use marginal revenue as price, but that doesn't really make sense. Remember, in the graph problem, we set marginal revenue equal to marginal cost to get our quantity, and then we go up to the demand curve, back to the demand curve to get our price. So it's the same thing here in the table. For the men now, we're going to produce as long as marginal revenue is greater than $5, so that stops being true here. So I'm going to sell 2 men's t-shirts, and the price I'm going to charge then is 8. And then we can calculate profit exactly the same way that we did before. That's going to be total revenue, price times quantity, and we can do that for each group here. So we've got 3 times 12 plus 2 times 8, right? Or you can grab that out of the table as you've already calculated. There's our total revenue. Oops, not plus, minus. Our total cost is going to, again, just be the cost of producing the t-shirt times, now we want the total number of t-shirts. So that's 2 plus 3. And then we'll add on our fixed cost. Okay, so the biggest mistake people make here is that they add the fixed cost twice. Because they calculate profit separately for each group, including the fixed cost both times. But you don't need to pay the fixed cost twice. You only pay it once, right? You pay the same amount no matter how much you produce. So just make sure that you're only including your fixed cost once here, and you should be fine. So what we have here then is, let's see, that's going to be, it's like 52 minus 27, which gives me a total profit of $25. And of course, this is going to be higher than in part B, where we had single price monopoly. The whole point of price discrimination is that the firm's going to make more money. And so profit with price discrimination will always be higher than profit in a single price monopoly. All right, so the last question then here is, how many shirts will the firm sell if it can perfectly price discriminate, and how much profit will it earn? All right, so the firm here now, if it can perfectly price discriminate, that means it can charge a different price to each individual consumer, is going to charge, is going to sell t-shirts as long as the consumer is willing to pay more than the marginal cost of production. So here that's true for all of them, right? So here we're going to get the socially optimal quantity, which is 6, right? We're going to sell 6 t-shirts because we're producing as long as price is greater than or equal to marginal cost. And to calculate profit, that's just going to be a little bit of a different calculation than what we had before, because we have a different price for everyone. So total revenue is going to be a sum of all of the prices in the market, right? We sell one t-shirt for $16, one t-shirt for $14, one t-shirt for $12, one for $10, one for $8, and one for $6. And then our total cost is going to be, again, quantity times marginal cost. Oops, that's 5 plus your fixed cost. All right, so you plug all that into your calculator, you're going to get profit of $34. And this will give you the highest profit of any of these options, right? The other thing that's important to note here is, what about surplus? What about economic surplus? So economic surplus is going to be highest in the case where we have perfect price discrimination, right? Because this is the socially optimal quantity. It has the most trades, it will yield the most surplus. Now, all of that surplus is going to the producer, but it will yield the most economic surplus. So in this case, your deadweight loss would be 0. The monopoly functions to restrict the quantity in order to increase its prices compared to competition, meaning that the single price monopoly is going to have the smallest number of sales and the smallest economic surplus, or the most deadweight loss. And then imperfect price discrimination is always going to be somewhere in the middle, right? In between single price monopoly and perfect price discrimination. All right, so we have one more example to go through on the next page. I'd like you to work through that before you watch the video or check the answers to make sure you're understanding what we're talking about here. And then that will be the end of topic 12.